And welcome to the Desk of Ladyada.
Hey everybody, and welcome to another Sunday night Desk-In. We're going to cover like a bunch of topics today based on the stuff that I've been working on all weekend. We had a good engineering weekend. Also went out for a nice walk far away from people. So I want to start off with some Adafruit news, some updates people are curious about.
Yeah, if you want to, you can look at our daily photo log, Adafruit Chronicles. You can also look on Twitter. Speaking of going for walks, so we have something called Path Reporter, which is like a contact tracer helper.
Yeah.
So it also has some new features like daily logging of your temperature. And that'll be expanded to Bluetooth thermometers as well. So every single day, I can report where I've been, and I can report my temperature if I choose to, privacy first.
Not stored in the cloud.
Yep, we have some other things going on. You did your city council meeting during the week.
That's right. Another one coming up. You
were appointed to the mayor of New York City's Business Advisory Council. So you did your homework over the weekend. We're sending that off to the team there about things to help restart the New York economy. And for now, though, we're going to do a little bit of GitHub actions and more. So take it away, Ladyada.
Okay, so first up, I spent almost all of yesterday, like 12 hours, converting the learning system repo that we have to GitHub Actions. So let's go to the computer and I can talk a little bit about what that is, because people, I don't think, know how useful and helpful it is to have automated continuous integration testing with embedded projects. It's something that software developers use, but hardware engineers tend not to, and I think that we can really benefit from it. We actually have a guide that we wrote a while ago called the Well Automated Arduino library, and this talks about using Doxygen to generate documentation and Travis CI to automate testing. So what do we mean by testing? So CI in this case does not mean there's literally an Arduino hooked up to the sensor or display and testing it. All it does is it, for example, downloads the Arduino IDE, installs board support packages, installs any other dependent libraries, and then checks that every example can be compiled. And you'd be surprised, actually, a lot of pull requests we get, like they don't compile, or something changes an API and you don't realize that it no longer works until somebody bumps into it later. What's nice about continuous integration is this happens all the time whenever you're interacting with your GitLab or GitHub repository. So let's show an example. So this is the Adafruit SGP 30 library. This is a simple library for a air quality sensor that I like. And we have two things. We have CI and Doxygen. So if we click on this, it actually takes us to actions. So you can see here, these are all the times that it ran. Sometimes it's, I committed something, and sometimes it's somebody submitting a pull request. In this case, somebody submitted a pull request and there was like a typo. And so it actually didn't pass. There's a little red X. I didn't pass the CI checks. And so that just means that I don't have to tell them like, hey, like you made a typo or you find it later. It doesn't find all bugs that people can introduce, but it like kind of gets rid of like the top 90% simple ones. And then when it passes, you can see here, this is Actions, which is a continuous integration that GitHub has for free. GitHub actually just reduced their pricing too, so it turns out it's like kind of a really good deal. Like you don't have to have another, there's other CIs like Travis and Circle, but now we try to use almost only just GitHub integrated. It's really, really fast, and it has parallel builds, and it has artifacts. It has a lot of nice details. So the first thing we do is, it's called pre-install, and we install all the, basically it starts up a new computer every time, a new virtual machine, running Ubuntu. So we install Python 3. We use Python 3 for some script parsing. And then in the next step, we install Arduino. So we actually install the Arduino CLI, the latest version, and we use that to do the compilation because it's the same underpinning Arduino IDE, but we don't have to actually, like the Arduino IDE itself is like a kind of a massive program. The CLI is very fast. It's great for continuous integration. After we install it, we update the core, and then we install using the kind of classic Arduino JSON URLs, for ESP8266 and 32 and Sandeep's NR55 boards and our Adafruit boards. We add those to the index, and then we install, AVR and ESP32 and 8266 and NR52. All of those package supports are automatically installed, and this happens in like 20 seconds. Is there a question?
Yeah, I just want to remind folks, if you want to ask questions, you have to do it over on adafruit.it/discord.
It's free.
Where you can join all 19,000 of us. There's a lot of us now.
Yeah.
And question that someone has is, why not GitLab CI/CD?
GitLab is probably fine too. We happen to use GitHub, and Actions has been really good for us. It's for CircuitPython especially, when we have 135 different boards, so each one has its own build, and then each one has 7 languages or 8 languages. It's a ton of work.
Quickly, on another tab, open up circuitpython.org/downloads.
Oh, yeah.
Yeah, just do that in another tab, and then let's see what's going on over there.
So for every one of these boards, we create artifacts that you can download, and this is done with CI. So basically, every time there's a commit or a pull request that's merged, it goes through and it compiles the firmware for every one of these different boards. Each one has slightly different pinouts, so it's like really nice to, even though it takes like an hour and a half, it's way better than having an individual do it.
Yeah.
Automation.
Go back to the top there.
Yeah.
131 boards. So we manage multiple versions of each board. So do the math with that. It's a lot, and we have multiple languages.
Yes, we just added Weblate too as well. If you're interested in adding contributing translations, Weblate has made it really easy.
Yeah, 131 boards. More than half of them are not even from Adafruit.
Yeah,
and
so
we have to manage all these different builds,
different languages,
all these different languages, and we think this is the most advanced system right now for doing microcontroller development. So let's return back to Ladyada.
Yeah, so back to the SGP library. So after we install the dependencies, we install Arduino. We go through, and there's only one test example in this case. It's called sgp30test.ino. And we check it. We compile it against an Uno, a Leonardo, a Mega, Arduino Zero, ESP8266 Huzzah, ESP32 Feather, Metro M4, so it's a SAMD51 chipset, and the Feather NRF52840, so it's a Nordic chipset. So we try to cover like one of each kind of chip. We just find that's a really good way to find, especially since there's things that come up with different compilers, and like the Tensilica compiler might be different than the AVR compiler, or might be different than the ARM compiler. You might find warnings or bugs that one compiler cares about and that others don't. So it's good. That's why I like to test a wide variety of these, all compiled. Again, it doesn't test that the sensor works. It just tests that it compiles. Then we do a Clang format check. So Clang format is my solution to, basically people would submit PRs and they would be using like Atom or Visual Studios, which would auto-format all of the C or C++ code with Clang format or something similar. And so we'd get like huge, the pull request would be for like one line change, but like there would be 500 changes because all the white space, like tabs and spaces, and then like the brackets would move and like comments would get shifted around. So having Clang format just means like all of our code passes Clang format. It's a little annoying because you have to like run it before you commit, but it means that everything lines up nicely and you have the same number of spaces. You don't have like a weird mix of tabs and spaces. It kind of takes care of all that for you. Then it does Doxygen. So there's no great way to do documentation, but Doxygen is just, it's been okay for me so far. The documentation lives in the code. It's just in a comment. It's pretty straightforward. And then what's nice is that if you go back to the repo, there's another button that is added, which is the Doxygen link. So when you go here, and this is auto-generated by Doxygen. Again, every time you commit, this is generated for you. You can go to the class, and then it will have documentation for every argument. return values, variables, parameters, basically anything that's, and then it actually has the file in line as well, which is handy. So this is our way of basically doing, we have, the documentation, but this is, and some people I just want to see a list of all the functions that are available, and it's go to Doxygen. So I do recommend it. We have basically everything you need. You don't have to write almost any code. You just copy and paste. We have a Travis CI document. You basically take this document and you put it in your GitHub repo. The only thing you have to change is the name, which is used for Doxygen, and then maybe whatever dependencies. And if you want to use actions, we'll update this guide for actions. It does a little bit more automatic dependency management, which is pretty sweet. And then we did the learning system repo, which is our repository for every project that's in the learning system. We used to have that code inline, and then with the thought that eventually we would be able to do this, we're okay, let's put all the code into one repo in subfolders. Python code, all the WAV files or bitmaps or what have you that go with the project, have it in one repo so it's very quick and easy to do some automated testing on it. Also, we were just we were having hundreds of repositories being created, every year. And it's not a big deal. I don't care how many we have, but it was, if people open an issue in one and somebody wasn't subscribed, you couldn't then assign them. It became a complexity. So this tests, each one has a different collection of examples. Every example only is tested usually by one platform. So for example, for Gemma, here's the list of every example. And you can see the Daft Punk helmet isn't a Gemma project, so it doesn't test that one, it skips it. But it does do NeoPixel ring hair dress and microphone flag. So between, there's a couple hundred different, let me see how many projects there are.
Yeah, I think this is an interesting trend because we're managing 131 boards. We're managing 2,000 tutorials.
Yeah,
we're managing 1,300 open source repos. And if you follow Open Hardware News, we're managing hundreds of open hardware boards that are now certified. We're the top certified.
So how do you manage
all these things together?
It's not a problem when people are only managing one library, but believe me, when you get to a bunch, it gets very complicated very fast.
And if you have one product that can run multiple types of embedded operating systems or can run different programming languages, we have to manage the most Arduino libraries. We have to manage the most Python libraries. Blinka is another flavor, and we have to manage all those.
Yeah.
So this is, I think, a really good...
Blinka is also on Actions.
Yeah.
We just check,
really good
Python...
view of what's possible now.
Python linting. So you can check out all the different projects here. So I actually had to fix up a couple of them. There were a few projects I was doing this. There was a few that were using an old version of a sensor library, and the API changed slightly. So I went through and actually fixed them, which is really nice. Some projects were missing a file. So that's the Actions project I did yesterday. So I do recommend people look into it. I don't think hardware people do CI as much as they should. You can start with Travis CI, and then, because we have a guide on it, and then you can look at our repos if you want to grab the GitHub Actions file. Okay, so that's that. Any other questions?
No, keep going. So you wanted to talk about some other stuff today.
Yeah. So some people emailed.
Oh, you know what? I'll mention one thing.
Yeah.
Our customer service for what library, what guide, updated hardware, bought a thing, have another thing, that all went away. Because there's always updated code on the guides, and there's always updated firmware you can get for your boards. So as far as oh, why do this? Why spend all this time? We've been working on this for now years altogether. Why? It's because better customer experiences, and it just works. So that is one of the things that we're really proud of. Back to you. You want to talk about some TI?
Yeah, let's talk about two TI Boost controllers. So basically every day people email me and say, why don't you have a Power Boost 3000 for the Pi 4? And it's kind of
I get those emails every day.
It's every day.
Yeah, I get those every day.
And so I was fine. I'll find a chip. So I actually went to TI's website. Maybe I'll show that, 'cause that's kind of fun. I also found this like weird site, DC selector, which I haven't used before, but it came up on a search, and it's just kind of cool because it's just like DC selector. I don't know. So let's go to ti.com, and then let's go to power management, and I want a DC step-up boost regulator. And then they had a nice little, well, they've got these nice featured products, one of which is actually the one I'm going to show soon. But here's a boost converter. What I like is it's really integrated. And this is my best, this is my favorite part of being an engineer. You just type in some numbers. So a LiPo battery ranges from about I'll put down 3 volts to 4.2 volts. And I want 5.2 volts output at 3 amps. Boom. So there's a couple parts here, and I don't need one that has higher range, and I also added, they never have price on, so I turned on price, and then of course it undid my things. Then I searched again, and this chip was really nice. It's 8 amps, can run as low as 0.5 volts. It has to have 2 volts to kind of start, but then the voltage I guess can drop. 5.5 volt output, 2.2 to 5 volt input, 1 output, fully synchronous and integrated. So, and it's 60 cents. Although this price, I will say, you add 40%, usually you can't get that price. It's not, that's approximate budgetary price, as they say. If you're a really big company, maybe you get that price, but for individuals, you don't. So this is a pretty sweet chip. So I looked at that, and then as I was looking at this, they were oh, check out the sister chip. This is also really nice. This is the TPS 61023, which is only a 3.7 amp switch. So that would note that the switch doesn't mean that's the current output. The switch just means the max input current that switch. So if you're converting 3 volts to 5 volts, it's about a 1 to 2 conversion ratio. That means this can get about 1 out of a 3.7 volt, you get 1.5 amps out. And this is also similar. It can run, it needs 1.8 volts to start, but then it can run down to 0.5 and still boost, although of course you probably won't be able to get a full amp. And it's really simple. I love these fully integrated switches, these converters. What's nice is also if they're synchronous, because there's an enable pin, and when you turn it off, it really cuts, you don't have current leaking from the input to the output, which is true for old style. And it's a 6-pin package. It's super tiny. And you need almost nothing. You just need the feedback path, capacitor, resistors, and then this is the layout. So this is the smaller boost converter. So I did make a breakout for this one, and I made it really small and cute. Load up the design. So I made it really small and cute. This is a little boost converter, and then you can see it's got just VN coming in here. By default, it's enabled. Ground output, and then power output. Very simple design. And VN ground output enable. You plug it into your breadboard, and you get 5 volts out at 1 amp, which is cute. And then for the 61022, again, this is that 8 amp switch. So that's 3 amp output at 5 volts, which is pretty massive. They even have that as kind of their hey, look, if you have the 3.6 volts, it's about a LiPo or 3 AAA batteries, you'll get about 3 amps at 95% efficiency, which is quite nice. So I designed also a PCB for this, called the Power Boost 3000. This chip is also quite small. And you've got power coming in here, and then power out here. also trying to use very large planes of non-thermal reliefed copper. I might go also with a 2-ounce PCB, depending. This is just a rough idea. You know, I have to, these boost converters, you do have to do a couple revisions because they're very sensitive to the layout, and sometimes you need a, you know, like extra capacitance on the feedback pins, and sometimes the switch pin needs something, so, you know, like some protection, but we'll see. So this is just, you know, input, one gigantic LiPo, output 5 volts, 3 amps. So as I was doing this, I thought this would be a good segue.
That's right.
Into...
We're going to start something new.
A new feature.
Yeah, we're going to start a new feature on Desk of Ladyada. This is, you know, live prototyping of new features on our shows.
Yeah.
So this one is going to be, we're going to name it something, but right now, it's called the Great Search on Digi-Key. Digi-Key and Adafruit, the Great Search on Digi-Key. Because Ladyada is one of the best engineers in the world searching on Digi-Key. And how she searched...
I know what to type.
How people have said, how do you find those things so easily when I see you on the shows? So we're going to do that right now, and this is a great search. Take it away.
Okay, so working on this chip, this boost converter, this 8 amp boost converter, or this 8 amp switch, the TPS61022, and there's not a lot of components you need for this. This is a very simple design. You just need a capacitive input, capacitive output, and some feedback resistors. But then you need this inductor. And the inductor actually is pretty important. You need to have the right inductor because the inductor is what uses, stores, and then you know, when you release it, the voltage increases on it, and that's how you get your boost conversion. So they do have some recommended inductors. And I like to use these as my guiding principles as I get some inductors. And I usually pick up a couple different ones. And I compare them. I compare the noise output. I compare the efficiency, you know, depending on pricing also. That can be part of it. Or EMI. There's all sorts of reasons. So let's look at what it takes to search for and find a good inductor for this product.
Some names: Digi-Key Quest, DigiQuest. All right,
DigiQuest.
Keep these names coming because we will think of something really good together. This is how it works. This is how we come up with feature names.
So the first step, you actually just search for the suggested inductor, and they do have it, which is rare. It's rare. Actually, sorry, no, it's out of stock for a full reel, but they do have it in cut tape. It's very rare for you to find the datasheet suggested inductor for sale. I don't know why. I think it's because people do tend to get custom inductors or something, but it's a rarity. Sometimes when you're searching for a part, I recommend using this product attributes like co-search, but because inductors, they have such slight variations in you know, the current rating. You know, like we might not find one that's exactly 11.5 amps, but we might find one that's 11.6. And so if you click on this, it becomes an exact search. Not so great. Also, the DC resistance is very, you know, it's in the milliohms, so it varies a little bit. So this is the one time I don't recommend using this search because inductors each one is unique.
Lots of choices
like a fingerprint
on the journey on the DigiQuest.
On the DigiQuest. However, there is one thing that we do know for sure, which is it's going to be a 1 microhenry inductor. So you start with the basics. There's a couple different options, but what we want is the fixed inductors, which is also where there's the most. Okay, so then the question is, how do you figure out which of these inductors you want? Because there's hundreds.
How do I figure out which? There's too many.
Too many.
Too many choices.
So there's 5,500. Too many. So here's some quick ways to cut down the number without sacrificing options. So the first thing I do is I select only active because everything that's discontinued or last time buy or obsolete, it's not what I want. I want something that's going to be around for a while. So that gets rid of like 1,000. So this is what it's just like. You just want to slice away.
With the Digi-Key search, you'll always have quantity. That's assumed. You'll have thousands of things that fit that that search, but now it's all about getting to the exact thing. So now you've already just chopped off 1,000.
You just chopped off,
Great.
and that's the easiest one because
Cool.
you always want the active, unless you're doing something special like repairing an old device. You need a matching
Cool.
inductor. In general,
All right, first thing.
active.
Active. Now
Next,
what?
mounting type. Now I know that I'm going to have a surface mount inductor, so again that gets rid of another 1,000 because I'm not going to have a through hole design. It's going to be surface mount. Great. The next thing I'm going to do is I'm going to look at the inductance. Now, sometimes you'll want to pick like, oh, it could be 1.01 or 1.1. So I'm okay with that. It doesn't do it, a huge job of reducing it, but it does reduce it a little bit, to select a range. It doesn't increase it much to select a range. So I usually just select a little range because I want it around 1 microhenry. Anything else here, way too much. And you'll notice because you typed in 1, it's it gets 331 because it's a sub.
Digimon Adventure was taken. Good name though.
Okay, so we're down to like 3,500 options.
All right, that's getting closer to the one.
To the one. Next up, I'm going to go only for shielded because I'll pay a little bit more to get shielded, so I reduce EMI. And that cuts down another 1,000. So now we're down to about 2,300, which is a lot. Now we're going to get even lower. I don't want bulk packaging. I don't want tray packaging. I only want the cut tape, digi-reel, and tape and reel. Sometimes I'll actually just search for cut tape because I don't want the full quantity. On the other hand, I found that searching just for tape and reel and then you can get the cut tape. Because right now, for every product that's in here, 3,000 or so, 2,000 products, you're going to have like a duplicate. You're going to have the digi-reel version, the cut tape version, the tape and reel version. So if you just select the tape and reel, now you're down to 1,000. Okay, so we haven't even done any really good specification searches, and you've already reduced the playing field a lot.
Yep, they're also saying BitQuest. I'm just going to keep coming up with good names. I'm going to keep mentioning them. So what are we down to? How close are we to the one?
We're down to 1,000.
Oh, that's great.
Yeah.
So
it's like a little video game.
5,000, now we're down to 1,000.
Okay.
It's like Tetris.
So now we actually have to look at the specs. So let's look at the specs. So it looks like you want the DCR. So the DC resistance is, of course, where you're going to get heat and inefficiency. You really want that to be as low as possible. And they don't recommend anything with higher than 8.4. So we go down to the DC resistance. And then we select everything up to 8.5. That got rid of 3/4. Now we're down to 340. Because it's like, that is quite rich. Because now it's like, okay, these are only the higher quality.
Little comment here. People say they also, Digi-Key has a great live chat. When people are searching, they can use the live chat, and they've gotten help that way as well.
Yes.
So let's keep going. So now what are we down to now?
We're down to 230.
Okay,
so
we're getting closer.
The next thing I'm going to do is I'm actually going to do a size check, because you actually usually do have a constraint on how big the inductor can be. And if you pay more for a smaller inductor with the same specifications, but to keep the same size as the other power boosts, I stuck with this, which is an 8x8 millimeter inductor, which you can see is quite big. And in the data sheet, they also recommend, somewhere between 5.5 by 5.5 to 8x8. So let's say, that is a good size restriction. You can see there's massive inductors. So let's go to 8.3. Maybe I'll do 8.4 by 7.9. All right, now we're down to 65.
Hyperfruit.
Yeah. Okay. So now you might do something like operating temperature, whatever other restrictions you may have. Height, which none of this really matters. Once you get down to like under 100, this is when I'm like feeling comfortable, when I actually want to start looking. Actually, sorry, we have to do the current saturation. It's not going to reduce it a bunch, but it's a good idea. So there's a calculation for the saturation. So they say here you want DCR as low as possible. You can figure out, let's do calculator. So V out 5 times I out 15 divided by V in, let's say 3 volts, divided by the efficiency, which is 80%. So 6.5 amps, and I think you want to have less than 40, for the peak to be current of less than 40% of the average inductor current for the maximum output current. So I think what they're saying is just like if you have 16 for the current flowing through the inductor, basically double that, which makes sense. This is almost doubling it. So they basically say 11 amps minimum, 28 amps max. 28 seems really high, but we'll cut it off so that it's 11 and a half because they don't recommend anything less than that. And it's good to have a slightly over-spec'd inductor in the saturation current. So let's select these. Okay, so now it's down to 45 items.
Okay, this is getting really close.
So now
5,000.
What's funny is actually the one that they recommend, I think, is here too, which is the 7443-16100. I see this family here. These are all looking pretty good.
Key Quest.
Key Quest. So the question is which one to get. Well, oftentimes, you're constrained by sizes and such. I do have one trick that I always do, which is when I search for components and they're all like kind of probably good enough, I will actually sort by quantity available, starting from the largest down. And the reason is that anything that they have a lot of stock of tends to be things that are popular and easily available. Whereas if there's only like one reel, it doesn't mean you can't get it. You definitely can get it, but it's just like, I feel kind of nice that there is this inductor that they have 75,000 of. It makes me feel like, ooh, this is one that I'm going to be able to get. I don't have to worry about somebody coming in and buying the reel under me. It's, a popular inductor.
Like engineering, like psychology.
It is a psychology thing.
Yeah, okay.
And it's a good price. It's also 60 cents for a reel. And so let's look at the specs. 12 amp current rating, 7.2 milliohms. There's also one that's 3.9 milliohms, which is even better. So I might get some of those too. This is taller. So you're gonna, that's the deal, is that you're dealing with a much taller thing. But the resistance is lower. So I'll probably pick up a couple of these. They are more expensive, which makes sense. You're going to pay, the thicker the wire, the lower the resistance. But I think I can pick up some of these. I can pick up some of these. So once you go to the procurement page, I like to go down to cut tape, and then I get it in the alternative cut tape package, and then I like to put down.
Okay, so is this, did you think you found what you're looking for?
I did.
Okay, so that was a painless process. There was a huge amount of information that you were able to sift through fast, and it's like a funnel.
Yeah.
A funnel of parts, and then you're gonna check out later.
Yes, I will check out later because I have to. I'm also gonna get that TPS 61022.
Okay.
And I might also look for some other inductors as well. Another thing that, by the way, I didn't check, but I usually do is if you need row house compliance, select that. And then I like to click on normally stocking. So they, obviously there's, if you need a special order, you get a special order. Some items are out of stock just because somebody purchased them and like they haven't gotten a refill. So if you're looking for like what are items that are generally available, which a lot of people who are doing like product development want to know, you click normally stocking. And that gets rid of any items that are like, so like this, for example, this inductor, it's like, oh, we don't have any in stock right now, but in general they do. They just are out right now. They have only 740 available over here, but it's a normally stocking part. So that means that you will get more of this later. You don't have to worry about like, oh, they only stocked it for this one time, and I'm never going to be able to get it again. So that's a common thing that engineers are like worried about. They're developing a prototype. They want to make sure that when they go to production, they don't get hit with this surprise, part unavailability, because then they have to go all the way through another redesign, which is unfortunate. So that's how to quest out your inductor.
We've got Digifunnel, maybe Digifunnel Cake, Hyperbit Fruit Quest Pro Edition. We got lots of choices, but this was the great search with Digi-Key and Adafruit. We hope to do this session. If you're on the Twitters or on Discord, please at Digi-Key, tell them, hey, this is a cool feature, and we'll kind of figure out a way to keep doing this.
Okay.
So that is the Desk of Ladyada tonight. Thank you, everyone. We're going to go have a snack. Don't forget, Discord is open 24/7. Join all 19,000 of us. We are shipping your orders. That's right. If you place an order right now, we're going to ship it. We do the essential orders first, but we're pretty much catching up, and thank goodness there is not the same need as there was weeks or even a month ago for a lot of the mission critical things. So we're getting back.
Yes.
So please.
I'm designing hardware.
Yeah. So please place your orders. It helps all of us. We want to stay in business. We have not laid off anyone. We have not done cut hours. We have not done any furloughing. We pay our contractors. Last night, tonight, Ladyada and I were there at Adafruit, had to do some wiring and some cleaning, and we were there with the cleaning folks that we've been working with for 6-7+ years already. If you want to get a gift certificate, that's great too. Want to get Adafruit.io? You can. We have Plus accounts. You can sign up for when we have Ada boxes, because we'll be shipping Ada box soon, and everyone who could get an Ada box signed up. Thank you. We'll be doing all of our shows this week. Don't forget 3D Hangout with Noah and Pedro. You got some John Park and some Make Code. There's Tuesday, and then John Park show on Thursday. We've got Ask an Engineer Wednesday at 8 p.m. and a show until 7 p.m. So we thank you for all of your support and more. We're still standing.
We're still standing.
We're still standing.
We're still searching.
We're still searching. All right. Thanks, everybody.
All right. Thanks, everybody. Have a great night.
Bye-bye.
Wonderful week.